Hello guys, my name is Crane. Welcome to Peri Solutions. And if you're new to my channel, please consider subscribing so that you don't miss out on any new content. Today we're going to look at the Pythagoras Theorem. So the Pythagoras Theorem states that the square on the hypotenuse side is equal to the sum of the squares on the other two sides. So we can write this like this: c squared, being the square on the hypotenuse side, is equal to the sum of the squares on the other two sides. So this will be equal to a squared plus b squared. So this is what we call the Pythagoras Theorem. Now let's look at these examples whereby we're required to find the marked sides. And before we look at these questions, it is very important that you identify your hypotenuse side. Hypotenuse side being the longest side, as well being the side that is opposite the 90-degree angle. Then of course, the opposite side or adjacent side, either way it is to work. So now let's start off by looking at A. So with A, we're required to find x. And there, x is the hypotenuse side. So we're saying x squared is equal to sum of the squares on the other two sides, 6 squared plus 8 squared. X squared is equal to 36 plus 64. X squared is equal to 100. Then now, we want x. So getting rid of the square, we square root both sides. So x would be the square root of 100, which is equal to 10. So this is for the first part, part A. Now, allow me to erase this. Let's move on to B. Now for part B, we see that 9 is the hypotenuse side. 9 is for the hypotenuse side. So we are saying for B, we're saying 9 squared is equal to sum of the squares on the other two sides. Two sides actually. So 8 squared plus x squared. So 8 squared plus x squared. But we want x. So we can say 81 is equal to 64 plus x squared. And taking 64 the side becomes negative. 81 minus 64 is equal to x squared. Subtracting this, what do we get? 81 minus 64, we get 17. So we see that we've got 17 being equal to x squared. Then we say for us to get rid of the square, we're raising both sides to the power of half, which is the same as square rooting both sides, such that x would be the square root of 17. So we can leave it like this, or we can simplify it further to get 4.12, and this is to three significant figures. 4. Okay, so it's 4.12. Yes, 4.12 to three significant figures. Now let's move on to B. So this was for B. So the trick is just to stick to the principle or the law of the Pythagoras Theorem. The square on the hypotenuse side is equal to the sum of the squares on the other two sides. So like we did here, 9 squared will be equal to 8 squared plus x squared. And then we simply solve for x. Now let's move on to C. Okay, so now for part C, what are we saying? We want to find x, x being the hypotenuse side, which is the longest side. But we also need this length, which we don't know. But we see that within this large triangle, there are two triangles. Yes. So now this right angled triangle, we've got 3 there, and then we've got 7 being the hypotenuse side. So this will enable us to find that length. Let's call it 1. So if we've got y there, so once we calculate y and we know that the total distance from there to there is 6, then we can calculate x being the hypotenuse side. So to calculate y using the smaller right angled triangle, hypotenuse side is 7. So for part C, we are saying 7 squared is equal to 3 squared plus y squared. Then we solve for y. So 49 is equal to 9 plus y squared. Then taking 9 this side, we're saying 49 minus 9 is equal to y squared. Then 40 is equal to y squared. So we can leave it like this. Why? Because we know that when we're dealing with this bigger triangle, we are saying that the hypotenuse side x squared is equal to the square of the sum of the squares of the other two sides. So x squared will be equal to y squared plus 3 plus 3, we get a 6. So this total length is 6, so plus 6 squared. And then this y squared is the one that we have there is 40. So we are saying x squared is equal to 40 plus 6 squared, that's 36, which is 76, such that x would be the square root of 76. And we can further simplify this to root of 76, that would give us 8.72. So x 8.72 to 3 significant figures. So this is how we do part C. Now let's move on to part D. Okay, now with part D, we've got unknowns, x, and then we've got an unknown x, and then we've got 8. So for part D, we are saying that hypotenuse side x squared is equal to the sum of the squares on the other two sides. So this is equal to 8 squared plus x minus 2 squared, like this. Then we now start simplifying this. So x squared is equal to 64 plus, if we expand this, we'll get x squared minus 4x plus 4, like that. And then this x squared, if we take it that side, it will subtract with that, and then we get a 0. And then as well, we can take 4 minus 4x that side, and it becomes positive. So we're saying this x squared minus that x squared plus, since it's now on the left hand side, plus 4x is equal to 64 plus 4. This will give us a 0. So 4x is equal to 68. Then dividing both sides by 4, x will be equal to 17. So that's the value of x. Okay, so this was for the Pythagoras Theorem. Please don't forget to subscribe, leave a comment, and share. Thank you.